Hey everybody, welcome. Just letting everybody in. Here's our double check on attendance. My check-in question for today is, what's your favorite way to get in some exercise, especially, during this time that we're inside and whatnot? Let's go ahead and put that answer in the chat so I could double check the attendance. So listening to music as a way to get exercise, that's good. Favorite way to get exercise. Okay, let's see. Going to the park with siblings that's walks and runs, cleaning. Yeah, cleaning is a great way. Doing some chores. Awesome, awesome. Let me just quickly get who just came in. All right. All right, so we got dancing, chores, going on walks, going down the stairs. Yep, the stairs sure do work. I work, so I do a lot of running back and forth. Yeah, that's what I miss. When I was in the classroom, you know, I'd stand all the time and like walk around a lot. So now it's like I have to actually like build in time to move because if I don't build in that time, it's not going to happen. So, yeah, those are all great ways. All right, we're just letting in a few more people. Just double check who I have here. As you all are coming in, we do have that check-in question. If you could go ahead and answer it in the chat so I could double check on the attendance, that'd be super, super great. All right, cool. So let's see who I don't have here. Yeah, running or jogging. Power to you, whoever has the I want to try to building some jogging maybe every morning. Uh, I haven't done that yet, but it's a good idea. All right, everyone. So here's who I'm missing. So based on the check-in and how fast I'm like trying to get everyone attendance. So I'm missing Tyree. I'm missing Jeanette. I'm missing Miles Green. I'm missing Alacia. And also Sit Lolly. Double check if I'm right or wrong. Let me know if you're actually here and I didn't get you. So, and if you're friends with them, if you could please send them a text. So again, I'm missing Tyree, Jeanette, Miles, Alacia, and Sitlali. So we're missing 4 people. Please send them a text to let them know to come into class so we're not marked absent. All right, everybody. So welcome, welcome. Welcome to pre-calc. Awesome check in there. Here's our agenda. If y'all could take a look at that. We just had our attendance check. We're going to be doing the entry problem for this unit. And that's going to be a group thing. It's going to be a Desmos group activity. It will be to be completed for credit. I'll talk a little bit about that once we hit there. And then we have an exit ticket. But it does depend how far we get into the Desmos and if we finish and so forth. So asynchronous number 8 was due on Sunday, so yesterday. If you did not get asynchronous 8 done, please get it done. I'm going to actually take a look and start putting grades for those tomorrow morning. So please, if you haven't got asynchronous number 8 done, please get it done. And asynchronous number 9 is already posted. This one is due Tuesday at midnight. So again, remember y'all, for pre-calc, my work is due Tuesdays, Thursdays, and Sundays. So 3 times in the week. And we just had somebody come in. I think that was Miles. Welcome, welcome. All right, cool. Let me know if anyone has any questions on the general agenda or the work that was due or anything like that. I'm happy to, answer. Again, office hours are a great way if you're getting stuck on anything to jump on in, get some help. Okay. Okay, so as a reminder, on Thursday, we did talk about something called Sigma notation. We even had the asynchronous number 8 based on like Sigma stuff. So we are going to learn more about Sigma, and it's going to come up more deeply in the unit. But we're going to go ahead and move on to a new entry task. So we're going to hold on to Sigma. We're still going to learn about this, and it's going to come back up again. So that's just the thing. Like last time we were doing this, now we're doing this. It's a new thing. Let's write this down. So yes, you should have some paper and pencil. Yes. Paper, pencil. Let's write down what we're going to be talking about today. So miles, I prefer just what is sigma instead of the WTF, please. And that's something we learned on Thursday. It's okay. That's something we learned on Thursday. I could send you the video on that, so it's okay. But for now, so I could send you the video. I did send it, I believe, on Remind to some of us. But if you didn't get that video, let me know. I'll send it to you. It's what we talked about and learned about on Thursday. All right. Okay, so let's go ahead and write this down. So this is what we're going to be talking about today, rate versus accumulation graphs. And here's our learning target that you're going to focus on. So I can investigate how rate graphs are related to accumulation graphs, both independently and also with my group. So let's take this time to write this down. And all right, a few more seconds. And then by the way, if anyone just came in, please let me know via private chat so I don't mark you absent. I heard somebody come in. Okay, so we wrote this down, and I'm pretty sure like a lot of this is like, what do you mean by rate? What is accumulation? Like a lot of maybe the vocabulary is like weird, right? Let's go ahead and talk about some of this. So here we go. Before you actually go into your groups and do this Desmos activity that I have planned for you, I first want you to process independently. So like think about it first on your own. Super important. So let me go ahead and talk about this entry problem. This entry problem is going to be the focus of our unit. And we will be using like sigma notation, what we learned last Thursday, later on in the unit to kind of incorporate and put together what we're learning. But for now, let me give you some examples on what is a rate graph and what is an accumulation graph. So here are the two separate samples. So right here we have a rate graph. Now it is a rate graph because, and let me just, sorry, somebody was coming on in. Okay, let me explain why this is right here on the left-hand side is a rate graph. Because look at the units here. This is the y-axis. The units right here for the y-axis are speed, miles per hour. Miles per hour is a rate. Do you all remember when we were talking about beats per minute, the heart rate, right? Like how doctors measure sometimes people's health. That's a rate. So is miles per hour because you have miles per something. How you would write it is like this, like miles over a fraction per hour. So that's what makes this right here a rate graph. Over here, we have the accumulation graph. It's an accumulation graph because for the y-axis, you have something that's increasing. In this case, miles or distance is getting accumulated. So that's what makes this an accumulation graph. And that's what makes the one on the left-hand side a rate graph. What I have right below the graphs are the corresponding table. So you could kind of see the different patterns and how the numbers are being brought about. So let me just pause that. I didn't like that I covered the 50 that was there. Let me see if anyone has any clarifications on what is a rate graph versus what is an accumulation graph. I see question marks by Jose. Did you have a question? Let me know. Happy to kind of re-explain. So right now what I did is I defined to you a rate and accumulation graph. And here's the part that I'd like you to do independently now for the next 3 minutes. Here are the questions that you'll be answering in your group, but for now I want you to answer independently. Number one, they're down here. How is the accumulation graph related to its corresponding rate graph? So in this case, how is this distance graph related to the rate graph? That's accumulation related to rate. And number two, how does each graph verify the other? So those are the two questions that you want to think about right now in the next 3 minutes. So please copy this down and try to answer these two questions in the next 3 minutes. Let me check out the chat. No, no problem. Okay, cool, cool. I thought there was like a super confusion happening. Okay, cool, y'all. So right now, let's do this on our own. Try to attempt to answer number 1 and number 2 as you're looking at these graphs, because we're going to be doing this together with groups on Desmos in a bit. All right, 3 minutes, we'll be back. Welcome back, everybody. So I hope some of y'all had some time to go ahead and answer, your initial thoughts about how is the accumulation graph related to its corresponding rate graph. So in this example, we have how is a distance graph related to its speed graph? And then how does each graph kind of verify the other? Like how does each one kind of like give you the other graph? So that's going to be the questions you'll be answering in your group today, but I first definitely want you to first do that on your own. Let me clear my screen. Okay, so let's go on to the next part, which is we're gonna have our breakout groups, and it'll be about like 30 minutes or so. And I'm gonna walk you through in a bit what the Desmos looks like. So my look fors, by the way, is of course be on task, use time. So I'll be sending like reminders like 5 more minutes or something like that. My expectations when I pop into different groups would be I should see group sharing of the screen and also interactions. We should be completing the Desmos task fully. And when I come in, it's not to help, it's actually to observe, unless there's like technical issues that someone needs help with. The Desmos code is going to be on Google Classroom, and only one person in the group joins. We're not having every single person join. We're just having one person in your group that's joining for you and also sharing the screen. So that's like the expectations of what's going to happen. This will be graded so that you get the points for your participation. I want you all to get your points because it's something I want to change from last module is that like I had a lot of async work that was graded, but I definitely want to start grading the stuff y'all are doing in class. So that's not like kind of unfairly weighted. So there's that. And let me show you the Desmos before breakouts. 1 second. Just so that y'all know what to expect here. So again, once you're in groups, I probably should have went to student preview, but once you're in groups, only one person is going to log in. The first screen is just reminding you what the learning target is and the picture. In the second screen, you all will be again deciding what your roles will be. And I believe I put it based on the letter of your alphabet. I think we did this grouping before, but you're going to have a new group this time. So you're going to decide who's going to do what. Everyone should have a role. Once you do that, you're going to answer some questions about the rate graph. Now it looks kind of cut off, but if you scroll down, you see the whole thing. And it's the same one that we worked on. Then you're going to answer some questions about the accumulation graph. Lastly, you're going to be asked to try to answer the essential questions that I asked initially. Then the last part, you're going to annotate and color code, kind of like making a poster here to justify your answers on number one, how is the accumulation graph related to the corresponding graph? And number two, how does each graph verify the other? So what I mean is annotation. So this slide should have like, you could do different colors. Click on here, yeah. Different colors to kind of like show and prove your answer and so forth. Or maybe you could do something with the table. Right here, this last side as a group, y'all are going to try to demonstrate your answer through color coding, through annotations, any way that y'all know how. And we're going to take a look at that together. So that's the general run through of what's happening in this Desmos. So again, it's only one person joining per group. So I see 2 people in here. So that means you might be the one that's leading your group because we're going to be randomized right now. So only one per group. So I should have in total like 7 or 8 groups joined once we do this. Let me clear this. I want to have that. All right, cool. So that's just the rundown of what's going to happen on this Desmos once your group gets there. The Desmos code is on Google Classroom. So let me just go ahead and get out of here. All right, let me go ahead and stop sharing my screen so I could stick you in groups. But first, does anyone have any questions before we begin? No? No questions? Cool. So I went over right now what's going to happen on the Desmos. Again, once you hit your groups, one person in your group is going to be the one joining the Desmos. So it's only about 8 groups should be in Desmos. And I'm going to be popping into different groups during the time, just there to observe, not really there to answer questions. But yeah, let's go ahead and begin. We're going to have about 6 groups. All right, y'all, I think we're ready. I'm going to go ahead and open all the rooms. All right, I'll see y'all in a bit.
Hey, Mr. Dano, I'm trying to share, but it says that the class disable participant screen sharing.
Okay, hold on a second. Let me stop sharing, my bad. There we go. Try it now. I hope it works now.
Yeah.
Okay, perfect. Whew, okay, thank you. That has been happening.
Can you see my screen now?
Yep.
Yes.
Okay, great. So I'm the facilitator. Who wants to be the?
It don't matter.
Wait, what you say?
It don't matter.
All right.
You will be the captain because I'm the recorder and somebody else already called timekeeper, so you will be team captain.
Awesome. And then this group, I heard y'all were discussing who's doing what. So whoever's the facilitator, if you could share the screen, if able to.
Yeah, just give me a moment right now.
Awesome, awesome. Just popping in to see how groups are doing. I'll be back in a bit.
Okay, what is everybody else doing?
So I guess I'll be the one to share my screen. Which one is it, team leader? Yes, no, okay.
We waking up hella late for no reason.
No, I'll be going to sleep for hella late for no reason.
Janet, bro, when you gonna drop that haul, bro? I'm trying to be your first subscriber.
Hello.
Hello, what's up, group?
The screen sharing it says it's disabled and I can't do it.
Try it. Wait, that's weird. Okay, try it now.
Oh, it works.
Yeah, I don't know. That's strange. Ooh, goodness gracious. Let's see.
Oh my god.
Okay, so it works now, right? I'm just hoping that's the case for all other groups. Okay, let me check in other groups, okay?
Is a tablespoon 2 teaspoons, or is it like a different measurement? A tablespoon?
Am I share whatever screen sharing? I think I am.
I can see it, Marvin.
In the rate graph, when the car has traveled 1 hour, how much distance did the car travel? How did you know you are correct using the rate graph or table? Explain.
Maria, are you the facilitator?
Yeah.
Awesome, awesome. So then, does anyone have any ideas about that first question in this group?
Doesn't the car go for 50 miles? Doesn't it go 50 miles in 1 hour?
Yeah, and then just go ahead and justify that. I think you're right. Was that Marjorie?
Yeah.
Yeah, I think you're right. Let's go. And I don't know who's typing that one now. Is that the same person, Maria, or?
Yeah, that's me.
Okay, perfect. Yeah, I think you're right, Marjorie. We just now as a group want to explain why. So you said in 1 hour it traveled 50 miles.
What information from the graph or the table helps you justify speed?
We can divide, right? The
Yeah.
distance by the time.
Not
Oh yeah,
50 divided by 3.
Because isn't distance divided by time equals velocity,
Yeah.
right? Yeah.
Yeah, it's also like the slope too.
Should I add something more?
Yeah, just probably put like how distance over time equals velocity, I guess. Just so they know like what we mean by that.
I gotta stir my syrup.
The reason why is because the. Oh
I'm not
no,
gonna
I can't type.
I'm gonna be real with y'all. I got my boobies out. Oh, I'm sorry. Wrong time. It's a good thing I have my camera off, Miss Sedano. I'm sorry. I'm just trying to keep the conversations live and everyone's spirits up.
Okay, that's okay. Thanks.
The reason why is because the graph is only at 50. Oh. Or every hour. Is that what we said?
Exactly. But
It says they're all 50.
I'm not sure about this one. Either 50 or we have to problem solve for something else.
sorry about that. I don't know. Because if you're still going, I don't know.
What did y'all say for number 1?
We said it was 50 miles
Okay.
because on the table the time was 1 hour.
And because it goes 50 miles per hour, it must have gone for 50. Okay, that makes sense. So if it travels for 3 hours, how much distance did the car go? If you know for 1 hour it did 50 miles.
So then would you multiply it by 3 to get 150?
What do y'all think? So we had the idea of, do we multiply by 3? Who said that, by the way?
Me, Juliana.
Juliana. Okay, can you explain why you think we would multiply by 3?
Because it's okay. Because it says when the car has traveled for 3 hours, how much distance did the car travel? So I'm guessing it's not the same. And since for every time it's still going the same amount of speed, since it's 3 hours, you would multiply it by 3.
Yeah, that makes perfect sense. What does this group think? So like Lali, Jose.
I was gonna say 0, but I don't think it's 0.
Because like y'all said for 1 mile traveled 50, right? 50 miles. And then then it needs to, so for 3 hours, so it can't be 0 because y'all already agreed that 50, right? So then for the next 3 hours, it's still going at the same speed. And I think that's why Juliana multiplied by 3. But then you could also sit, Lolly, explain why you think it's 0. That's a good idea out there that we could tackle.
Well, I was gonna say 0 because the miles per hour hasn't changed.
The miles per hour hasn't changed. Okay. And using miles per hour, this question is asking about total distance, right? Like using speed is trying to get from that, like how much distance did it go? The speed looks like it's the same, right? The speed hasn't changed. Speed is constant. But just because the speed is constant, does that mean it didn't travel any distance?
No.
It's still going 50 miles per hour.
Okay, so yeah, and then Jose in the chat put also no. Awesome. All right, I'm gonna jump into other groups. Interesting discussion y'all are having.
So do we all agree that it went 150 miles or not?
Yes.
Never mind. I see why.
Is it because it's just like, how do I say this? I don't even know.
Like it's because like we're like for this we're measuring just the speed. So every hour, like regardless of how many hours have passed, we're
Yeah,
always
it's not
traveling.
adding up, huh?
Yeah,
It's just saying, yeah, okay.
yeah. But then for the distance, like they add up because it's like each hour you're traveling 50 miles, so you add that up.
She said breakout number 2 is on the last slide. Woo.
Okay. Do y'all want to add anything?
Doesn't this graph show that the speed isn't changing because it's just going straight and it's just like the distance increasing?
Yeah.
Because the question also asks what information from the graph or table helps you justify speed?
So then how should I explain it?
The car distance between 50 miles every hour. We know this because I'm not sure. Like, kind of just say that the speed doesn't increase, it stays the same, and that's why it like kind of goes upwards like that, and it doesn't go like for a curve or anything because it stays the same.
Okay.
Hey, Mr. Dano, we
Same.
finished.
Oh wow, yay, y'all are finished. Okay, I'm gonna give groups like maybe 5 more minutes and then we're gonna come together. Awesome job, y'all.
Thank you.
Welcome.
It's just an amazing group.
Yes, awesome. It was all random too.
150 times 3, right?
Where'd you get 450 from?
Never mind. I multiplied.
450? Wait, I'm confused. Where are we at?
I think we're on the okay.
Yeah, but like within the problem, where are we at?
Because it's okay, so it's talking about the speed. And in order to get the speed, you would divide the distance and the time.
Oh.
So I think it would be, I think it's like with this one, wait. With this, it just shows the speed and how constant speed. And then this one, it actually shows you the distance of how far it traveled. But I think the speed is still 50. But we just have, yeah, if that makes sense.
So we have to divide the distance by the time?
Yeah, that's what I did. Does that make sense for what I did?
Yeah, it does.